Hello all, welcome back. We'll continue with our series or playlist on Numpy. The topic for today is fancy indexing. We have already learned what about indexing. Indexing is like it's zero-based indexing in Numpy also, same like Python. We can access like this. We can do slicing. How we do slicing? We can provide the row and the column like this, right? So anything before, like from the start and the end, right? We can specify. We can also specify if it's a multi-dimensional with comma, we can specify, and all those things we have already learned how to do slicing and indexing. In the last video, we also learned about the Boolean masking, right? How we can, this is a Boolean array, and how we can do a Boolean masking like this, right? Okay, let's learn another way of indexing, which is also very useful, and that is called fancy indexing. To understand that, let's first define a array. Okay, so I've defined an array. How I'm defining? I'm getting the size of 10, rand int between 0 to 100 in random integers of the size 10. So I get a single dimensional array like this, right? Suppose we want to access the three different elements. Okay, so what we can do is we can write something like this, right? x3, x7, x2, and we can access that, correct? There is another way of accessing these, right? And that way we can access it just by passing the index of these elements, right? So similarly, how we are passing here, we can pass it in a different way. What we did is we create a index array or an index list. We'll create an index list. What we want, we are trying to retrieve the element at index position 3 in element at index position 7 and element at index position 4. We created a separate list, and this list we are passing into X like this. What will happen, and this is called fancy indexing, the resulting array will be my element of an array with the element as these indexes. So what was the index 3? Index 3 was 0, 1, 2, 3. Okay, let me run this. Yeah. What was my place 3? 0, 1, 2, 3, 23. It has 23. What was 7th? 4, 5, 6, 7, 13, right? 13. What is my fourth position? 0, 1, 2, 3, 4, 35. So it gives 35. So the resulting array on this index list is the elements or the array comprised of the elements which I am trying to retrieve, right? So I hope, friends, you are getting this fancy indexing concept right. Instead of doing it like this, which is more clumsy, x3, x7, and individually accessing, I'm passing a list of indexes. I'm passing a list of indexes to my array, and the resulting array is all the elements from those indexes. That's what it is. You can do this into a multi-dimension also, right? And the way to do that is, suppose the resulting array we want is at a 2 cross 2. Okay, so what we'll do is we'll specify the index positions 3, 7, 4, 5. Okay, and then we call x on top of it. We'll get a 2 cross 2. Now friend, x was a single dimensional. This is critical. X was a single dimensional, but the resulting array is a two dimensional. Why? Because the dimension of the resulting array when we provide an index list depends on index dimension, right? Depends on index dimension. What was the dimension of the index? 2 cross 2. My resulting array will also be 2 cross 2. It will not depend. It is only fetching the values from here. But the shape of this, the shape of the resulting array will be the same as my index array, not as on which it has been called, right? Critical difference. Fancy indexing also works in multi-dimension. You can see it over here. I created a 2 cross 2. What I will do is, I'll give it a row and column. So my row index array, these are index arrays. I defined as 0, 1, 2. Column, again index array, I have defined as 2, 1, 3. And then I called it on top of X. What will be the shape of this? The shape of this, right? So my row and column I am providing. Okay, so 0, 2, my first element has to be row 0 and column 2. Row 0 row 0 and column 2, 0, 1, 2, 2. So the first element will be 2. What will be the second element? 1, 1. That means 5. 5 comes over here. What will be the third element? The third element is 2, 3. That means second row 0, 1, 2. Second row, third column 0, 1, 2, 3. 11. 11 comes over here. This is how fancy indexing works, friends. Okay. With that being said, I will close this video and I will see you all in the next.